So today we're talking about dividing rational expressions once again. We learned a trick yesterday. Well, we extended a concept we already knew, that when you were dividing two fractions, you could simply multiply by the reciprocal of the denominator. And today we're going to do the same sort of thing, but I've just got kind of a weirder looking thing for us to consider, which are called complex fractions, which, let's see, what the official definition here says is a rational expression whose numerator and or denominator contain rational expressions. What? They're like fractions within fractions. I'll just say that. Fractions within fractions. Nested fractions is maybe a way a programmer would talk about it. So complex fractions, what do they look like? That would be something like this. It would be like 2 halves. Nope, that's not very exciting, but whatever. Plus 1/3 all over 3/5. So like fractions within fractions. All right. Or I could have x plus 1 over 2x squared minus 16 all over x squared plus 2x minus 1 over x plus 3. All right, complex fractions. And notice in this case, in order for me to indicate which fraction is the major fraction, I have to draw kind of like this vinculum a little bit larger than those other two. Right? So it's this fraction divided by this fraction is what's going on there. All right, so those are what complex fractions look like, something like that. And today we're going to talk about simplifying them. Oh yeah, just for some lingo. So this is my own lingo here. So this would be the denominator, right? El mayor denominator, right? Denominator. And then up here would be your numerator. And then I call these pieces right here. This is my own Mr. Waddy lingo right here, copywritten. I call those guys, get this, I call them denominators. Denominators. Right? You got it? Isn't it good? I don't have a name for the numerator, the mini-numerators. What? Numerators? I don't know. But denominators sounds good. That's what I call them. And that word will actually be helpful in later sections. So, not official math language, but on the street, that's what all the mathematicians call them. So let's do an example. The mathematical street, using our sidewalk chalk, writing out numerals of pi and such. Yep. So here we go. Let's do an example. So what if I've got 5a squared minus 20 over 2a plus 2, and then bigger vinculum, right, divided by 10a minus 20 over 4a. So we'll go through the same process of factoring everything we can and trying to cancel stuff out. But what do you think we could do with this? I also call this particular type of situation, bless you, I call it a stack-o-frac. It's just like a stack of fractions, right? Fractions stacked on top of other fractions, like some sort of Jenga pile that we have to sort out. Yeah. So I call this a stack-o-frac. This I would not call a stack-o-frac because there's like sums or differences of fractions within there. Those ones we're not going to do today. We're going to look at those maybe in a couple of days. So, really, I mean, what does this giant fraction bar vinculum mean? What operation does it tell us to do? Yeah, divide, right? So I'm just dividing, I'm dividing this by this. And technically we already did that yesterday. So when I divide by a fraction, what should I do? Yeah, multiply by the reciprocal. So let's factor this guy up top here. Does anyone see some strategies for this, the upper numerator? Yeah, GCF. Actually, that's the other thing I'll call it, is like the upper numerator, the lower numerator, upper denominator. It's kind of like saying like upper, lower, middle class. Like, I always thought those were odd, ways of classifying things, but it works. It looks like also I'll be able to yoink yoink a 2 out of those and a 10 out of these. So I'm just going to, rather than having to switch colors all the time. So I'll have 5 times a squared minus 4. Ooh, boy. That should just, like, jump out at you like a pack of ninjas in a dark alley. Just, like, you should spot that right there. Like, it shouldn't sneak up on you, But it should be so obvious, like, I see you guys hiding behind the trash can. Like, is it possible to, like, embarrass a ninja? Like, just, like, shame them, like, I see you over there in the corner, and then just, like, stand up, like, okay, you got me. Like, I think that's how you defeat a ninja, right? You just have to embarrass them, like, I spotted you. Yeah, that's true. Because there's actually, like, apparently out in, like, California, I forget the name of this city, but there's an actual dude that was dressing up as Batman and fighting crime. And, like, Batman in the movies, like, that guy's cool. Like, like, he's sneaking up on those criminals, but, like, real life Batman, like, he'd be walking around the street, like, you'd see him all the time. Like, Batman in the movies, like, somehow he's getting rooftop to rooftop, and, like, suddenly just appears and disappears, and then you don't see him again. But, like, what happens if you see this, like, crime-fighting vigilante Batman dude, and he's just, like, you see him, like, walking down the street, and he's like, I'm just looking for crime today, you know how it is. Like, wouldn't that be weird, just seeing Batman, like, when he's not fighting crime? Because he's not sneaking up on him very well, I don't know. So that's what it reminds me of. Yeah. So a squared minus 4 should be, like, just an obvious ninja hiding behind a trash can. Like, psh, you don't have anything on me. So here we go. Anyways, 2 times a plus 1 would be what I get there. And I'm going to change this into a multiplication of the reciprocal, the flipperical of the denominator, right? So this lower numerator becomes my new denominator down here. So this is 10 times a minus 2 over, and it looks like just 4a. I don't think I can factor anything with a 4a. And like I said, there's one more factoring there we could do. It's a shame to have to write everything over again, but that's all right. So what is this factor to be? No. A plus and a minus 2's, right? Yep. So far all day we've been having the a plus 1, a minus 1. And that's definitely why you've gotten into the habit of that. Because 1 squared is 1. Yep, that would do it. Very possible mistake there. For a over 10 times a minus dose. And now I can fruit ninja a little bit. 2 goes into 2 once, into 4 twice. Oh, there's some more. 5 goes into 5 once and into 10 twice. Oh, there's some more. 2 and 2. Bam, bam. That's right. And an a minus dose and an a minus dose. Wow. And now it's tricky to pick up this mess, all this, sort through these carcasses of factored and canceled things to find what's left. It looks like we've got a times a plus 2 over a plus 1, I'm guessing. Now question, can I do this? Super illegal, right? I can only cancel an a with another a, which was its like a factored version of a. And a plus 1 can only cancel with another entire a plus 1. All right, so don't be I guess I'm glad that you're tempted, like you're on the lookout for canceling things, but just be aware. So that's the idea. I don't know. Let's try one more just for fun. If you think you viewers online got this concept already, you could probably stop the video here. It's not gonna get too much more complicated, or at least take a glance at this problem maybe. Let's see. So what if I've got here we are, x squared minus 10x. Let's see, plus 25 over, and let's say I've got x squared minus 16 all over, right, megavinculum. Man, that's so gonna be my gamer tag. Megavinculum? Dude, what? At least my motto, I don't know. I think my current motto on Xbox Live is Smitty Werbin Jaegerman Jensen. He was number 1, so that's what it is. True story. 2x squared minus, let's do 50, all over, and let's do x squared plus, let's see, 7x plus 12, I think. That sounds good. Whew. Man, it's tricky coming up with factorable polynomial expressions. So let's factor this. I guess I can fit it over here again. Let's see. So what do these factor to be? Actually, oh, this one I could. Yeah, actually, better yet. Well, it doesn't matter if you wrote it that way. That's fine. I'm going to write it like this. Ba-ba-bam. That's right. Does anyone know how to this numerator factors? X minus 5. Yeah, that's like the numerator, denominator. Yeah, there we go. So the numerator, denominator, how does that factor? Yep. I like to put the positive one first just because I'm an optimist, but it doesn't actually matter. Commutative property of math, multiplication right there. Let's see. So this is now going to be my new denominator. And what could I do here? GCF, yeah. Let's take out a 2. And also I'm multiplying by the reciprocal over here, so that's what's going on. So I'll have 2 times x squared minus 25. And then that one will factor to be, I think that's x plus 3, x plus 4. Let's see, equals. I guess we can fruit ninja a little early if we want. Swipe. And then we'll have x minus 5 squared times x plus 3 over x minus 4, or 2 times x minus 4, I guess. And then what's this factor to become? Yeah, there you go. See, now you're a positive person. Isn't that much better? I guess maybe good news first, bad news second. Maybe some people want to hear the bad news first, so then they can all right, now that that's over with, I know I've got good news coming. I don't know. And what cancels out? Yeah, so this cancels out with one of those, leaving 1. Good old properties of exponents coming back. So x minus 5 times x plus 3, all over 2 times x minus 4 times x plus 5. Wow, thing of beauty. Right, so today's lesson, Noah's Mouse Mall. Yeah, matter of 14 minutes, and the second problem probably wasn't even necessary. And there was a story about Batman, actual real-life Batman, or dude pretending to be Batman. Well, I don't know, could,
There's been so many Batmans, there's not one Batman.
That's true. Wouldn't that be funny if it was just actually like George Clooney? He's like, I used to be Batman in one of the movies, but not anymore, and I still want to be Batman. And like now he's just dressing up and fighting real life crime. I don't know. That'd be interesting. It'd be embarrassing, like if I put out a bat signal and then like George Clooney and Val Kilmer and all those other dudes, just like all of them showed up and then like awkwardly are like, oh, it's weird. Right? I don't know. I think that'd